we're going to go over standard costing direct labor variances. If you haven't already reviewed the direct material variance video, please go do that first because we're going to build on that here. Direct labor standards, just like direct material standards, have a quantity and a rate. So the standard to make a unit, a finished good unit, might take 4 hours of time at $9 an hour, or 30 minutes of time at $20 an hour, or 0.2 hours at $14 an hour. It'll be specified how long should it take and at what rate should we pay the labor. So you can be wrong in a number of ways. You can be wrong by spending too much time or too little time. You can be wrong by paying at a higher or lower rate, or actually you can be wrong by both. The two variances for labor are rate variance and efficiency variance, and they parallel pretty nicely the price variance and the usage variance for materials. So the rate variance is a price variance just for labor, and it compares, just like with materials, the rate you should have paid with the rate you did pay. The efficiency variance is similar to the usage variance for materials. So instead of how much material did you use, it's how long did it take you. That's the quantity for labor, is length of time. So we compare how much time you should have used, given how many you made, using the recipe or the standard costing, and we compare that to how long it did take them. If you like formulas, here it is in formula format, and so you can write this down in your notes and use this, or you can use the reasoning, which is what we did in the prior slide. So let's do one together. Let's say that a product has a standard labor cost of 0.4 hours, that's the quantity, at $15 an hour, that's the rate. So if you made 12,000 finished products in the month and you spent $75,500 on 5,000 direct labor hours, what's the labor rate variance? So now we have more information than what we need, so we've got to dig out what we need. So for the rate variance, we should compare what we did spend, $75,500, with what we should have spent, which was $15 an hour. So we have to convert that 75.5 into what is that per hour. And so we would divide that out and figure whether we paid more or less than the $15 an hour. The other way we could also do it is by multiplying that 5,000 hours times the 15 and see if it was bigger or smaller than the 75.5. Algebraically, identical. So we paid $75.5, which is $15.10 per hour. It's unfavorable. Why? Because it's greater than the 15. The difference is 10 cents an hour for each of the 5,000 hours worked. So we have an unfavorable direct labor rate variance. What about the labor efficiency variance? We had enough facts in this problem to do the other variance as well. Now the labor efficiency variance compares how long it took you with how long it should have taken you. So it took them 5,000 hours to make the 12,000. So how long should it have taken them? Well, for each of those 12,000 that they made, they should have spent 0.4 hours. So we compare the 5,000 that they did use, or how long it took them, compared to the 0.4 for each of the units that they finished. And it's unfavorable because they used 200 more hours than they should have. And we don't leave the 200 hours in that format. We actually convert it to dollars by multiplying it times the standard rate, and that gives us a better feel for how big a problem is the variance when it's in dollars instead of hours. So now let's do an interpretation. So we had the labor rate variance, which was $500 unfavorable, and we had the labor efficiency variance, $3,000 unfavorable. Which one of these four explanations best matches these variances we calculated? So freeze the frame and think through it, and then we'll talk about it. So let's go ahead and just go through all four. A, supervisors work while new hires are being trained. Supervisors are paid at a higher rate. So that would lead to an unfavorable rate variance. So that one is consistent but it's not consistent with the labor efficiency variance. The supervisors would expect to be the most capable because they're the ones doing the training. So the likelihood that they're going to be much slower than standard is not very good. That would be the rookies that would be slower than standard, but not the supervisors. So the rate piece is consistent with A, but not the efficiency piece. So we don't like A. Let's look at B. Temporary workers carried overflow volume at higher than usual rates. Let's read that again. Temporary workers. So temporary workers are probably cheaper. Carried overflow volume, so they worked the extra stuff that was after hours at higher than usual rates. So that could work because there's an unfavorable rate variance because they were at higher than usual rates. Temporary workers are probably slower than standard because they don't know what they're doing yet. They're not trained. So B looks pretty good. Let's look at the rest. New workers at a training wage were slower than standard. All right, so here we would expect the new workers to be slower than standard, that we would expect an unfavorable labor efficiency variance. But if they're at a training wage, that's below the average rate, so then we should have a favorable rate variance. So C doesn't match. And we don't need D because B is a pretty good match. So now you're ready to go work some on your own.